solve the following Bernoulli's differential equation. So we got x squared dy over dx plus 2xy equals y cubed. Okay, this is almost linear, right? We have y dy over dx and some function of x squared, and some function of x, that's the independent variable, that's 2x, equals, for linear we need a function of x, but we got y cubed, not a function of independent variable. So not linear, but this is the only place where the function, I mean this linear, this is not linear because of this one. That's the only place. So this is Bernoulli's equation. And here how we solve is we just transform with correct substitution. We transform this into a linear. Okay, let's new variable something b, let's say dv over dx, some function v equals some function of x, some function of x. And then after it is linear, we know how to solve. We need to find an integrating factor and go from there. Okay, you might have to review how to solve a linear. Okay, so for that we divide both sides by y cubed. So make right hand side just a function of x. So divide through by y cubed. This is x squared over y cubed. Here 2x divided by y cubed, right? So y to the negative 2 equals 1. So we can have function of x, but no y. Now this y to the negative 2 is our v, new variable. V equals, let v be y to the negative 2. So we are transforming into a linear. So we need dv over dx here. So since we have dy over dx, let's find derivative of both sides with respect to x. So dv over dx equals derivative with respect to x. So n y n minus 1, so negative 2 minus 1 negative 3 times from the chain rule dy over dx. Okay, now we need to isolate dy over dx because we want to convert this. Divide both sides by this, 1 over negative 2y to the negative 3 dv over dx equals dy over dx. We can simplify the left hand side a little bit, and dv over dx, this negative to the front, let's move y to the negative 3 to the top, so y to the positive 3, right, over 2 equals dy over dx. Okay, let me erase this one, dy over dx. Okay, now with this equation, then equation star becomes, let's see, we got x squared over y cubed, and dy over dx we found over here, dy over dx is negative y cubed over 2 dv over dx times y cubed over 2 dv over dx. Okay, that is plus 2x, y to the negative 2 is v equals 1. Okay, let's simplify. Y cube cancel. We should not have y anymore. Okay, this should be a linear in terms of v and independent variable x. Okay, negative x squared over 2 dv over dx plus 2x v equals 1. Now v prime or dv over dx, function of x, where x is an independent variable, and function of x. So this is linear, but we don't want anything here, so let's divide by negative x squared over 2 which is same as multiply through by negative 2 over x squared. Okay, let's multiply, then this cancel, dv over dx. So we are multiplying, right? So negative, positive, negative, 2x over x squared, one copy of x cancel, 2 over x, and I have v equals 1 times negative 2 over x squared. Okay, there is a mistake here. When I multiply 2 times 2, it has to be 4. Okay, this one, because we are multiplying by 2 over x squared, right? 2 times 2, 4. Now this is linear in v, dependent variable v with respect to x. Now we know how to solve this. Okay, if you don't know, you need to review linear ODEs. So linear, that means we need to find integrating factor. Integrating factor is e raised to integral of this function in front of v, which is negative 4 over x dx. That is e raised to negative 4, pull in front of integral sign. Now 1 over x dx, that's the natural log of x. Negative 4 here, so e ln x raised to negative 4. Now e and ln cancel, x to the negative 4, which is 1 over x to the 4th. That's the integrating factor. Now we multiply both sides of this. I mean, here we are assuming x is positive, obviously, because I did not write absolute value. So multiply both sides of this by x to the negative 4. Okay, this is this, let's say, dagger. After we find the integrating factor or an integrating factor, then this equation becomes, left hand side will be automatically d over dx. So we basically multiply through by this one, and automatically the left hand side becomes derivative of dependent variable times integrating factor equals multiply the right hand side by x to the negative 4th. This is 1 over x to the 4th. Okay, so negative 2 over x squared and 1 over x to the 4th, so x6. Okay, I mean, you might have to review linear ODEs first. Now we integrate both sides. Integrate both sides, we get v times x to the negative 4 equals, when we integrate, this is x to the negative 6 on the top. So negative 2 x, using power rule, this is on the top, means x raised to negative 6. Negative 6 plus 1 divided by this. Oh, that is negative 5 plus c. So v times x to the negative 4 equals, negatives cancel, 2/5 x raised to negative 5. I want to put on the bottom, so positive 5 plus c. Okay, this is 1 over x4. X to the negative 4 is 1 over x4. So let's multiply through by x4. Then v equals, and this is 1, 2 over 5, 4 copies cancel, x5 means 1 copy left, plus c times x4. Okay, that's v, almost done. But v was y to the negative 2. Okay, that is y to the negative 2 is 2 over 5x plus cx4. Yeah, you may leave here. Okay, pretty much this is 1 over y squared. This is 1 over y squared. If you want to try to solve, then it will be 1 over everything. This is implicit solution. This is good enough.